When talking about the wonders of the world, we think big. However, there's a lot of hidden wonder, intrigue, and mystery in the microscopic quantum world. For example, can an object exist in two different states at the same time? Surprisingly, the answer is yes in the world of quantum particles. The phenomena of superposition in quantum mechanics explains that a particle can exist in multiple states simultaneously. All fundamental particles have a property called spin, which means that they have angular momentum and an orientation. Let's consider a photon. The quantum phenomena of superposition shows that the spin of fundamental particles, such as a photon, could be clockwise and counterclockwise at the same time. Now, let's split the photon into an electron and a positron. We say that these two particles are now entangled because when one observes the spin of either the electron or the positron, it instantaneously determines the spin of the other particle, no matter how far apart these particles are, even light years away at the other end of the universe. This phenomena of quantum entanglement was referred to by Einstein as spooky action at a distance. For example, if the electron is spinning in the clockwise direction, instantaneously the positron will be spinning in the counterclockwise direction. Let's see how these two wonders of the quantum world, namely superposition and entanglement, can be used to create a powerful computer. In computers today, information is represented as sequences of bits of 0 and 1. In quantum computers, information is represented as qubits, which can indicate a property of photons or electrons, such as polarization or spin, respectively. For example, a clockwise spin can be denoted as 0, and an anti-clockwise spin can be denoted as 1. Because of the property of superposition, unlike bits, which are 0 or 1 at a single instance, qubits can be in any proportion of 0 and 1 at the same time until observed or measured. For example, let's take a sequence of 4 bits. Conventionally, this sequence can only be in one of 2 to the power of 4 or 16 combinations. However, since each qubit can be both 0 and 1 until measured, the qubit sequence can be all of those 16 combinations at once due to a property called quantum superposition. When it is required to determine the value of qubits, we need only measure some of the qubits and deduce the value of the other qubits using the principle of quantum entanglement. Determining the value of only one qubit will instantaneously determine the value of all of its entangled partners. These principles of superposition and entanglement have led to a new paradigm called quantum computing. Although a current digital computer can compute 2 to the power of the number of zeros and ones representing information, it takes a long time to solve real-world problems in medicine, cryptography, and other fields of application. For example, internet search, being compute intensive, requires thousands of computers for a single search query. However, a quantum computer can be used to explore multiple different states at the same time due to superposition and entanglement. So for example, a 300 qubit quantum computer can be used to calculate all the information in the entire universe, and a 1000 qubit quantum computer is 100 million times faster than a conventional computer. So therefore, a single quantum computer can replace thousands of conventional digital computers. Quantum mechanics concepts of superposition and entanglement have moved beyond the realm of physics as a theoretical model to practical applications. In summary, studying the wonders of the quantum world can have a deep impact on our lives and our way of living.